In this video, we're going to do another example of writing a function, and we're specifically going to write a function for this. This is the HC-SR04 ultrasonic sensor. And what it does is it essentially emits out ultrasonic waves, or very high frequency waves that we can't hear, and it sends them out from these things that are speakers. That's why they kind of resemble speakers. So it sends them out, and then it kind of counts how long it takes for those sound waves to hit an object and be reflected back to it. And so this right here kind of shows this timing diagram for it. So on here there are two different pins. There's a trigger pin and an echo pin. And so the trigger pin we will treat as an output from our Arduino to send this 10 microsecond trigger pulse that says, okay, hey, start emitting those high frequency sound waves. And so once this thing receives that trigger input, what will happen is it will then send out these 40,000 kilohertz sound waves, or sorry, 40 kilohertz or 40,000 hertz sound waves from here, and then count how long it takes for them to come back. And the way that it does that is it does that with the echo pin, which is something that we will read on the Arduino as a digital input. And so once it sends all those out, this echo pin goes high, and it continues to stay high, or at 5 volts, until it gets those pulses back, and then it goes low. And so what we can do is turn on our trigger pin, and then we count how long this takes before it goes low again, and use that time difference to compute how far away something was. All right, so we're gonna start off by wiring it up kind of in this configuration here. So there's 4 pins. They're labeled as VCC, trigger, echo, and ground. And so VCC is gonna go to 5 volts, echo is gonna go to a digital input, trigger is gonna go to a digital output, and ground is gonna go to ground. So I'm gonna just plug these here and start to wire it up. So I got my VCC is down at the bottom here, and just make sure that you're plugging it into the correct one as they are labeled, because it kind of depends on which way your thing is oriented, which way the pins go. And so the top one there is ground, and then let's see, in my program here I said I was going to do the trigger pin as 3, so my trigger is here, so I'm going to plug that into 3, and then my echo I said was going to be 4. Right there. All right, so let's go into a new sketch here, and we will start to write code for this. All right, so let's go like this. And so what I'm going to start with is I'm going to start with defining macros for my pins here. So I said that my, let's see, 3 was the trigger. So I'm going to say trig pin as 3, and then I'm going to define the echo pin as 4. And then inside of here, what I need to do is I need to set up the serial port, because what we'll do is we'll print out the distances that it's reading to the serial port. So I'll say serial.begin 9600. And then I need to do my pin mode for each of these to get them to work properly. All right, so I'll say the trigger pin is going to be an output, and the echo pin, echo pin, if I can type today, is going to be an input, just like that. And so I think that's all the setup that we need. And so what it's going to entail is some code that resembles this down here, right? So it said that we need to send the trigger pin to a high state, or set it to 5 volts for 10 microseconds. And so that's what this code is for here. And then what we do is we count how long the pulse is high. And so that's what this special pulse in is it returns back some time that is how long that is high. And it stores that information as a long, which again is just a special type of integer value that can store larger values, because sometimes when we're working with time, it's like a very long stretch of time. And then what we do is we take that time that we get, this time in microseconds, and we convert that to a distance. And so sound travels at 74.727 microseconds per inch. So if I take this duration in microseconds and I divide it by that, that should give us the distance that those sound waves traveled. But it's important to know that the sound waves will leave the ultrasonic sensor, hit something, and then be reflected back. So what we need to do is divide that by 2 to get the distance that something is away, because it's essentially traveling double the distance, right? It's traveling there and back again. And so what we're going to do is we are going to bake this into a function. It's a great candidate for creating a function so that we can use this and call this over and over again whenever we need to. We can copy this function across different projects that use an ultrasonic sensor, or even just invoke the get distance several different times. And so what I'm going to do is I'm going to copy this all right here and bring it into the project. Okay. So this kind of describes a little bit of what's happening here up in some comments, but the name of the function is getDistance, and what it does is it returns back some integer value that is the number of inches away that it is detecting something. And it does that using that process that we just described, setting that trigger pin high for 10 seconds, and then counting how long the echo pin is high, and then doing that math to convert it from some duration to some distance here. And so what we could do is we could put this call to this function inside of loop, because loop's going to run over and over again, and we can just see how that value changes as I move my hand in front of it. So what I'll do is I'll declare some integer variable called distance, and I will set that equal to get distance, okay? Because get distance, we can see by the method signature or method header, does not take any input arguments here because there's nothing between the parentheses, but it does return back a value that is that distance in inches. So we can store that here. It has that return value because it says int here, and the very last line says return that value. And we first compute it as a float because we're dividing it by these decimal values, but then we can convert that float to an integer value just because it's easier to work with a little bit by saying int and then passing that value inside of there. So what we're going to do is we're going to call this function. It'll give us that distance back, and then we can just print it out and see if it works. All right, so let's run that. Let's do that and bring up the serial monitor, and then let's bring up our camera. So looks like it's done. All right, so it's reading 43. I think it's hitting something, kind of my wall over here off to the side. But as I bring my hand in, you can see the distance gets smaller and smaller. All right, and then as I stretch it away, let's see if I can shift it down this way. All right, so as I move it away, I know it's off screen, but I am moving my hand like this. So that's how the ultrasonic sensor works, right? And if I pick it up entirely, it starts to read something that's now 16 inches away. My chair is right over there. If I re-angle it, it might hit something kind of farther away. Or if I point it up, there we go. Now it's hitting the wall that's 45 inches away. So yeah, that's how that works. And like I said, this is a very great candidate for building a function like this, because then every time I need to use something like an ultrasonic sensor, I can just copy and paste this function, and we know that it works the way that we would expect. The one thing that's important is that in order for this to work, you have to have macros for trig_pin and echo_pin. If you wanted to change where those were located, you could just change the numbers right here in those macros, or we could, in theory, if we wanted to, provide arguments for the trigger pin and the echo pin. Say maybe we had multiple ultrasonic sensors. That might be helpful if we wanted to say, hey, read the ultrasonic sensor that might be on the left side of my project versus on the right side of my project. But this is sufficient for what we're going for here, and this is a great function that we just wrote.